Welcome back to International Conference on Current Research Trend 2025. Let's move to first day of keynote session. I am going to chair this session with my co-chair, Dr. Naveed Ahmed. I invite our first keynote speaker, Professor Dr. Muhammad Aslam from Department of Statistics, King Abdulaziz University, Saudi Arabia. Dr. Aslam, are you hearing me? We need to call Dr. Aslam.
Assalamu alaikum warahmatullah. Can you hear me?
Yes, sir.
Okay.
Please share your screen.
So, can you see my screen?
Yes, sir. Please go.
Okay. Bismillahirrahmanirrahim. Assalamu alaikum warahmatullah. Ladies and gentlemen, we welcome to all participants to the conference today because the assigned topic for me is the nutrosophic logic, a robust framework for quantifying the and intercept. I cannot see 1 minute. Yes. Interpreting uncertainty in natural sciences. So I am Professor Muhammad Aslam from King Abdulaziz University, Jeddah, Saudi Arabia. So the background of the presentation is the motivation and background, neurosophic logic, objective of work, application domains, comparative review analysis, future research directions, and conclusion. So what is the motivation and background for this neurosophic logic? Real world is inherently uncertain and incomplete. Classical and fuzzy statistics have limitation. Neurosophic logic introduces truth, indeterminacy, and falsity, provides a robust framework for complex scientific systems. The brief description of these title is that in real world, data is usually incomplete, uncertain, and therefore the use of fuzzy statistics and classical statistics has their limitation that they ignore the degree of uncertainty while analysis the data using classical and fuzzy statistics. So what is the neurosophic logic? Neurosophic logic is introduced by Florentine, which is the extension of classical and fuzzy logic. Because in fuzzy logic, usually we consider degree of truth and degree of falsity. But in neurosophic logic, there is addition of degree of indeterminacy or degree of uncertainty. So neurosophic logic is actually the extension of classical logic and the fuzzy logic. And it is in the sense that the neurosophic logic consider 3 degrees of uncertainty, degree of indeterminacy, degree of falsity, so which make more informative than the classical and fuzzy logic. Then, based on the neurosophic logic, there's the introduction of neurosophic statistics. So in classical statistics, we use only 2 degree of measures, degree of falsity and degree of truth. But due to the neurosophic logic, there is an addition of the third degree of measure, which is known as degree of uncertainty. So, neurosophic statistics is usually a generalization of classical statistics designed for imprecise and interval data. And when we have data in interval or data is imprecise, then we can use neurosophic statistics instead of classical statistics or even interval statistics. Capture randomness and indeterminacy simultaneously and more informative than interval statistics because interval statistics only provide the data analysis with lower limit and upper limit and ignore the very important degree of uncertainty even data is recorded under the uncertainty. But interval statistics do not utilize the degree of uncertainty, which is the limitation of interval statistics and even classical statistics. Then interval representation only neurosophic variable, explicit handling of indeterminacy, improved interpretation of uncertain measurement, enhanced decision making. So these are the key aspects because while performing the neurosophic analysis, we are in the position to interpret the degree of uncertainty, degree of truth, and degree of falsity while doing the analysis. But these measures are usually not covered in interval statistics or even in classical statistics. So this is the advantage of neurosophic analysis on the interval statistics and classical statistics. Objective of the work: comprehensive review of neurosophic statistics, highlight application in applied sciences, compare neurosophic and classical approaches, identify future research direction. Because this is a new area of the research, neurosophic statistics, and there is a lot of work we can do on different directions, and we can improve this theory further. And this is under process. And many people from the world, they are working in different directions using the neurosophic statistics nowadays. So application domain is actually is not limited to these areas, but in all areas where uncertainty is presented. To quantify the uncertainty, the use of neurosophic statistics is very useful. Just like bioinformation and medical sciences, if uncertainty is presented, then the use of neurosophic statistics is more desirable as compared to the classical statistics or even interval statistics. Then sensor technology, macroelectronics, material sciences and nanotechnology, and astrophysics. So in these areas and in many other areas, just like political science, engineering, reliability analysis, environmental sciences, and economics. So there are many areas where we can expect the uncertainty. The use of neurosophic statistics is useful. Bioinformation application, just like in bioinformation, medical diagnosis under uncertainty, AI-based healthcare decision system, COVID-19 data analysis, improve diagnostic accuracy with neurosophic statistics, because when we expect that our data is imprecise or our data is in the interval form, then the use of neurosophic statistics is more informative than the classical statistics and interval statistics in bioinformation application area. Then we have the sensor technology, and in this area, the use of neurosophic statistics is much informative and suitable because analysis of the humidity and tactile sensor data, capacitance and resistance measurement outperform classical statistics for imprecise sensor output, enable reliable interpretation of experimental data. If, for example, in the sensor technology, when we are uncertain about the data or measurement error is presented, or we cannot accurately present data in these areas, then instead we use classical statistics or we use interval statistics. The use of neutral statistics is preferable because this is more informative than the interval statistics and classical statistics and gives the information about the degree of uncertainty as addition as compared to the classical statistics and the interval statistics. Then microelectronics and applications, just like we can expect uncertain data in supercapacitor and LCR meter reading, manufacturing and environmental variability handling. So neurosophic method provide invariant relationship, superior handling of interval value data. So if we expect the uncertain data in macroelectronics applications, then the use of neurosophic statistics is recommended because we can get the information about the three measurement. Number one, degree of uncertainty, degree of truth, degree of falsity, which is degree of uncertainty, which is totally ignored in our classical analysis, just like in classical statistics and in the interval analysis. Then another potential area where we can expect the uncertain data is material science and nanotechnology. Just like data related to the log melting point analysis, this data may be usually uncertain and can be expressed in interval form. Then nanotoxicity assessment, graphene form resistance studies, heavy metal contamination analysis. So in these areas, it is highly expected to record the data in the interval or imprecise form. So instead, we perform classical statistics or the interval statistics analysis on this type of data. It is preferable to use the neurosophic statistics to get expand result and to interpret result uh, more clearly as compared to the classical statistics and the interval statistics. Then another area we can see the application, we can explore the application of neurosophic statistics is the astrophysics application. Just like in the physical laws with the indeterminate validity, energy and momentum conservation analysis, and then Samaranrache geometrics. Actually, this is the name of the Florentine Samaranrache, who is the founder of neurosophic logic, and then handling contradictory physical propositions. So actually, this is also a very good area where we can explore the use of neurosophic statistics. And if our data, our recorded data is in the interval form or imprecise data or uncertain data or not accurate data, so the use of neurosophic statistics is very useful in this area. Then neurosophic method outperform classical statistics, more flexible and informative because neurosophic statistics always provide the results in the interval form. Also, if data is in the interval, we can also get the analysis results just like if we calculate the simple statistics just like arithmetic mean, median mode. So this is the beauty of neurosophic statistics that it gives result in the interval form. more flexible and informative, because due to the flexibility, we have 3 degree of measurement here: measurement, degree of uncertainty, truth, and falsity. Therefore, this is more flexible and informative than the classical statistics and interval statistics. Suitable for modern scientific challenges, because in the complex, when data is recorded in the complex situation, then usually uncertainty is there. And in the presence of the uncertainty, so it would be better to use the neutrophobic statistics instead of classical statistics or interval statistics. Applicable across multidimensional area. So we discussed a few areas, and a few other areas just like economics, environmental sciences, reliability analysis, industrial statistics, quality control, even in survey sampling. When there is the uncertainty, neurosophic statistics is useful as compared to the classical statistics and the interval statistics. And then development of the algorithms using the AI to generate random data. Usually the existing algorithms only provide the data under the certain environment. So the algorithms which are being used in the AI, these can be extended using the neurosophic statistics, and this is very good application nowadays, because many people are working with the domains in the artificial intelligence with their areas, just like they are working in physics, chemistry, whatever their area. The AI is really, they are merging their topics, their areas with the AI. So the use of neurosophic statistics across multi-dimensional domains is very important nowadays. And then we have the for the future research directions. Actually, this is a new area, and it has potential applications in almost all areas where we have uncertainty in the data. And usually, when we talk about the data, we say uncertainty is there. We cannot say that our data is 100% accurate. So when uncertainty is there, then the use of application is recommended, because it is more informative than the classical statistics and the interval statistics. So it can be used for the future direction, broader application in nanomaterials, okay, then dark matter and other modeling, integration, and AI. This is the very, very hot area, AI and machine learning, and using the neurosophic statistics in AI and machine learning, is a very good area for the future research. And then validation across new application domains, just like economics data. Economical data is usually uncertain. Then the use of neurosophic statistics is good. And then just like environmental data is usually recorded in under uncertainty, and reliability data is usually recorded under uncertainty, and then survey data is usually recorded under uncertainty. So whenever uncertainty is presented, the use of neurosophic statistics is recommended. At the end, we have some conclusion that neurosophic logic is a powerful uncertainty framework, because this is the extension, this is the generalization of fuzzy logic, and in the sense that it is also extended form of classical statistics and neurosophic the interval statistics. And the neurosophic statistics becomes classical statistics when there is no degree of uncertainty. Enhances analytical accuracy and flexibility, because it always provides the results in interval form. Therefore, we are very flexible in interpreting the final result. Strong potential to transfer natural sciences. Yes, because when the uncertainty is there in all these areas, then the use of neurosophic statistics is good option as compared to the classical statistics and interval statistics. Then recommended for complex real world data analysis. Yes, for example, in the flood measurement, this is the complex, just like nano material measurement, this may be the complex. So for the complex real world data, and because in these situations we cannot get accurate data, then it would be better to use the neurosophic statistics by using the degree of uncertainty, and this will make our result more flexible, more informative as compared to classical statistics and interval statistics. Thank you very much.
Thank you, Professor Aslam, for your excellent and useful talk. If now it's time for question and answer. Anyone want to ask some question, please ask to Professor Aslam.